Now let's take a look at naming ionic and molecular compounds. Molecular is just another word for covalent, so you could just easily say covalent compounds. So the easiest way to tell if something is ionic or covalent, because there are different naming conventions, is to look at what it's made out of. If it has metals and nonmetals, it's an ionic compound. If it has only nonmetals, it's covalent. So in naming ionic compounds, it's pretty easy. It's just the name of the cation, which is the positively charged metal, followed by the name of the anion with the ending "ide." There are no prefixes, but in some cases you'll need to specify, such as in the case of the transition metals, the metals in the middle of the periodic table, which charged metal are you looking at. So let's take a look at FeCl2. So Fe is the symbol for iron, and Cl is the symbol for chloride. So the name should be iron chloride. But like I said, iron is a transition metal, so it can exist as iron 2 or iron 3, meaning iron with a 2+ charge or iron with a 3+ charge. Because over here we know it's iron with a 2+ charge, because each chloride has a -1 charge, we know that it's iron 2 chloride. Also, an acceptable name would be ferrous chloride. This is the old name before the standardized name came out, so this is the classical name. It's based off of the Latin name, ferrous, and a few transition metals can be named that way. I wrote them over here. So Fer, meaning iron, Cup for copper, Stan for tin, and Plum for lead. If you're looking, because all these can form two possible charges, the one that has a smaller charge has the ending OUS, such as ferrous. So lead could be plumbus, but also if it has a higher charge, such as iron with a 3+ charge, it wouldn't be ferrous, it would be ferric with an IC. If we take a look at covalent compounds, the name of the element, you need to name the elements in the order that they appear in the formula. In this case, there are no prefixes for the first if it's a mono, so if there's only one. But if there are 2, 3, 4, or anything else, you need to state the prefix. You always need to state the prefix, though, for the second element that appears. So let's take a look at a couple of examples. N2O5. So because there are 2 nitrogens, we need to specify that there are 2. So that's dinitrogen, and because there are 5 oxygens, we say pentoxide. OF2, because there's only 1 oxygen, we don't need to write monooxide or monooxygen. It's just oxygen, and because there are 2 fluorines, because it's the second element, we need to say it's difluoride. So now let's try going from the name of the compound to its formula. So again, there are 2 conventions depending if it's ionic or covalent. But if it's ionic, there are 2 things you need to keep in mind. The first is you need to know the charge of the ions, and the second is the charge of the compound overall needs to be 0. So let's take a look at calcium bromide, for example. So you could mistakenly write it as CaBr because there are no prefixes. That's wrong because you didn't take into account the overall charge of the compound should be 0. Calcium forms a 2+ charge, whereas bromide forms a -1 charge. So you're going to need 2 bromides to counteract the +2 charge of the calcium to give it an overall 0 charge. For naming covalent compounds, it's a lot easier because they have prefixes telling you how many you have. So something like sulfur trioxide, remember, because it's the first element, we don't need to write anything, so there's no mono at the front, but we know it's 1. So S, and then trioxide, 3 oxygens, SO3. One more thing to keep in mind is HON and the halogens. So HON standing for hydrogen, oxygen, nitrogen, and the halogens are the halogens on the periodic table. So fluorine, chlorine, iodine, those guys. So whenever somebody refers to hydrogen, oxygen, nitrogen, or any of the halogens in their gas form, it's always going to be diatomic. So you always need to write it as H2, O2, N2, Cl2, and so on.